In the previous video, we discussed the major blocks of a power system. Hi, I'm Hassan Obaid. In this video, we will focus on the generator set paralleling control. Cummins pioneered the first onboard microprocessor-based generator set control in the early 90s. The PCC 3300 I'm holding in my hands is Cummins' latest generator set control, and it's responsible for all the paralleling functions, such as first-start arbitration, synchronizing, load sharing, load govern, load demand, and protection, which includes a UL-listed overcurrent function called amp sentry. Also, the voltage regulator is integrated to the power command control. So let us discuss these functional blocks one by one. When two or more generator sets start and reach their 90% rating of voltage and frequency and are about to close their electrically operated circuit breakers to a de-energized bus, their phase, voltage, and frequency are most likely out of sync. So the first start arbitration comes into play. This is a control function that is used to prevent multiple generator sets from closing their circuit breakers simultaneously to a de-energized bus since they are out of sync. Initially, only one generator set closes to the bus. Every generator set has an equal chance of winning this arbitration. Hence, this is called random access to the bus. After one of the generator sets wins the first start arbitration and the bus is energized, the remaining generator sets match or synchronize their voltage, phase, and frequency to the bus and then close their paralleling circuit breakers. At this stage, all the generator sets can close to the bus simultaneously. Had the bus been energized by some other power source, a generator set or a utility source for example, then the first start arbitration does not come into play, and the generator sets all synchronize and close their electrically operated paralleling circuit breakers simultaneously. It is worth mentioning that whether the paralleling power system is comprised of 3, 5, 20 generator sets or even more, arbitration and synchronizing do not necessarily take longer since the paralleling controls operate autonomously. Now that the power sources are synchronized, the next step is load sharing. Load sharing is the proportional division of kW and kVAR total load among multiple generator sets in a parallel system. Load sharing is essential to avoid overloading and stability problems on the parallel generator sets. Load sharing can either be isochronous, where voltage and frequency stay constant at 100% regardless of the load, or droop, where the voltage and frequency vary as the load varies. Obviously, the advantage of isochronous load sharing is the constant voltage and frequency. However, it requires the sources to communicate with each other. On the other hand, droop does not require communication interconnection between the power sources at the expense of varying voltage and frequency as the load varies. The power command control has the capability to do both functions, isochronous or droop, as well as load sharing across different sized generator sets. The load govern function applies when a generator set or multiple sets are parallel to a utility. Because the utility voltage and frequency are fixed, the generator sets regulate their kW and kVAR output instead of their frequency and voltage. Thank you for watching. In the next video, we will discuss generator set protection and amp sentry.